Hello there, and welcome to the Sleepy Science Channel. Tonight we'll be exploring one of the largest and oldest ecosystems on our planet. The very place where life began and where creatures continue to evolve in the darkness. The oceans are one of the most spectacular wonders on Earth, full of vibrant life and undiscovered mysteries. This journey moves beyond the familiar and into the vast world below, into deep waters where light slowly disappears and the environment changes completely, where pressure reshapes bodies, where animals glow, drift, hunt, and survive in ways unlike anything on land, where entire ecosystems exist without sunlight, powered by heat and chemistry rising from the planet itself. There are towering underwater mountains, endless plains, deep trenches, and silent migrations that happen every night on a global scale. Much of this world has never been seen directly, yet it plays a role in shaping life across the entire planet. What follows is an exploration of that hidden ocean, the strange creatures that live there, the forces that shape it, and the reasons it remains one of Earth's greatest unknowns. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, just breathe. Let your eyes grow heavy and let the deep sea cradle your thoughts. Let's begin. The ocean covers more than 70% of Earth. When you look at our planet from space, it isn't green or brown. It's blue. Over 70% of our world is covered by ocean, stretching unbroken for thousands of miles in every direction. The Pacific alone is so large, it could hold all the continents combined. This immense body of water shapes everything about life on Earth. The climate, the air we breathe, even the rhythm of our days and nights through the tides. It absorbs heat from the sun, moves it around the globe, and creates weather patterns that ripple across continents. And yet, when we stand on the shore, it feels like a horizon, a boundary, the edge of the world. But the truth is, it's the ocean that defines our planet. Earth isn't just a rocky sphere in space, it's a water world. We have explored less than 5% of it. Despite all our satellites, submarines, and scientific advances, we've seen only a fraction of what lies beneath the surface. Less than 5% of the ocean has been explored, which means 95% of it is still a mystery. We know more about the surface of the Moon and Mars than we do about the deep sea. Vast mountain ranges, endless plains, and hidden trenches stretch for thousands of miles unseen. Entire species live and die in darkness, never yet glimpsed by human eyes. Each expedition reveals creatures so strange they seem like science fiction. Transparent jellyfish, glowing predators, and fish with anatomy unlike anything on land. The ocean is not just unexplored, it's almost entirely unknown. And that means every dive is like stepping onto an undiscovered planet with secrets waiting in the dark. We've mapped more of Mars than our own ocean floor. It may sound unbelievable, but we know more about the surface of another planet than we do about the sea floor beneath our own waves. Thanks to orbiters and satellites, over 99% of Mars has been mapped in high resolution. The ocean floor, only about a quarter. Much of it remains an indistinct blur, inferred from satellite gravity readings or sonar echoes. We've explored the deep with robots and submarines, but the scale is staggering. Earth's oceans cover over 70% of the surface, and their depths are difficult and expensive to reach. As a result, there are canyons, mountains, and entire ecosystems we've never seen. New species are discovered every time we look. In a way, the deep ocean is our last true frontier, an alien world at the bottom of our own, and it lies just beneath our feet, quietly waiting to be understood. In the deep, pressure can crush a submarine like a can. As you descend into the deep ocean, pressure increases fast and dramatically. Every 10 meters down adds another full atmosphere of pressure, the equivalent of the weight of the entire sky. By the time you reach just a kilometer deep, the pressure is 100 times what we feel at sea level. Go farther, and it becomes thousands of times greater. At the deepest trenches, the force is more than 8 tons per square inch, enough to crush steel, collapse submarines, and turn hollow objects into twisted wreckage. But astonishingly, life survives, even thrives under these extremes. Creatures down here are soft-bodied, boneless, and uniquely adapted. Their biology is shaped by compression, their movements slow and ghost-like. For us, this realm is lethal. For them, it's home. The crushing weight of the deep is one of its defining features, and one of its greatest mysteries. The ocean's deepest point could swallow Mount Everest with room to spare. The Mariana Trench in the western Pacific Ocean holds the record for the deepest point on Earth. At its lowest measured spot, the Challenger Deep, the ocean plunges to nearly 11,000 meters. If you placed Mount Everest inside it, the peak would still lie more than 2 kilometers below the surface. This trench is not just deep, it's profoundly alien. Temperatures hover near freezing, the pressure is extreme, and yet, even here, life persists. Microbes thrive in the mud, arthropods and strange fish flit through the dark, and we've only just begun to explore it. Fewer people have visited the Challenger Deep than have walked on the moon. Each descent requires precision engineering and nerves of steel. But with each journey, we learn more about the limits of life, the shape of the planet, and what waits at the bottom of the world. Life flourishes there without a single ray of sunlight. Sunlight is the engine of life on land and in the ocean's upper layers. But in the deep, light never comes. And yet, astonishingly, life continues without photosynthesis. Instead, deep-sea ecosystems run on chemosynthesis, a process where bacteria feed on chemicals like hydrogen sulfide, which bubble up from hydrothermal vents. These bacteria become the base of the food web, nourishing creatures that have never seen the sky. Some animals, like giant tube worms, don't even have mouths or digestive systems. Instead, they host bacteria inside their bodies and absorb energy directly from them. This partnership between microbe and host allows entire ecosystems to bloom in the dark. These strange, sunless communities have reshaped our understanding of biology and the possible conditions for life beyond Earth. If life can exist here, it might exist in the deep oceans of other worlds too. The ocean soundscapes are as complex as forests. When we think of the ocean, we often imagine silence. But to a hydrophone, an underwater microphone, the sea is alive with sound. Whales sing in deep, haunting tones that travel across entire oceans. Dolphins click and whistle. Shrimp snap their claws like underwater fireworks. And fish croak, grunt, or drum on their own bodies. Together, these voices create soundscapes as rich and layered as the calls of birds in a rainforest. The ocean is never truly silent. Sound travels farther and faster in water than in air, making it the primary language of the sea. For creatures living in darkness, sound is sight, communication, and connection all at once. To drift in these soundscapes is to hear the ocean breathing, humming, and whispering with life. A chorus that has been singing for millions of years beneath the waves we barely know. Entire continents drift on plates beneath the sea. The ocean is not just a surface of water. It is the skin of a living, shifting planet. Beneath it lie tectonic plates, enormous slabs of rock that move slowly over Earth's mantle. These plates carry entire continents with them, drifting a few inches each year. Over millions of years, they break apart, collide, and reshape the face of the Earth. Oceans open and close like slow breaths, and mountains rise from the sea. The Atlantic Ocean, for example, is still widening today as the plates on either side move apart. This drifting explains why fossils of the same species can be found on continents now separated by thousands of miles of ocean. To imagine continents floating on vast plates of stone is to see Earth as alive, always changing. The ocean is not just a boundary between lands, but the stage where worlds are formed. The ocean still holds mysteries we cannot yet imagine. For all our ships, satellites, and submarines, most of the ocean remains unexplored. More than 95% of it is still a mystery. A realm of darkness and pressure where unknown creatures may drift unseen. Each expedition brings discoveries, new species, new landscapes, even new chemical processes. Yet, the vast majority of the deep remains untouched by human eyes. Scientists believe we may have seen less of the seafloor than of the surfaces of Mars or the Moon. Somewhere in the abyss, there may be creatures with forms we cannot picture. Ecosystems unlike anything we know. The ocean is a reminder that our planet still holds secrets. That mystery is not confined to distant galaxies. To close your eyes and imagine the unknown depths is to feel wonder and to dream of what might still be waiting in the silent dark. The sea is both our origin and our future. Every life on Earth traces its beginnings back to the sea. Billions of years ago, the first living cells floated in its waters, nourished by the chemistry of the deep. From those tiny sparks, all plants, animals, and humans eventually arose. Even now, the ocean sustains us, giving us food, oxygen, and a stable climate. And as we look toward the future, the ocean may again hold the key to our survival. Its currents regulate the planet's temperature. Its ecosystems support our fisheries. And its depths may one day reveal medicines, energy sources, or even clues to life on other worlds. To stand on the shore is to stand at the edge of both our past and our destiny. The ocean is not just where life began. It is where life continues and where humanity's future may ultimately return. Other creatures are nearly invisible, and that's on purpose. In a place with no shelter, no rocks or coral to hide behind, the best defense is to vanish completely. Many deep sea creatures have evolved bodies that are almost perfectly transparent. Their skin, muscles, and even some internal organs are made of jelly-like material that barely bends or reflects light. The result is a near-invisible body that predators can't easily detect. Some fish are so transparent you can see their skeletons. Others, like the glass squid, are nearly invisible except for their eyes, which they disguise using mirrors or special pigments. Even their blood lacks pigment to reduce visibility. In the deep ocean, visibility isn't just about hiding from predators. It's about survival at every level. To float unseen through a world without shadows is a powerful adaptation. In the quiet dark, transparency becomes a form of armor. Elegant, ghostly, and nearly perfect. The gulper eel can open its mouth wider than its own body. The gulper eel is one of the deep sea's most surreal residents. a shadowy creature with a whip-like tail and a ballooning jaw. Its mouth is so massive, it can open wider than the eel's entire body, forming a kind of living fishing net. Despite its fearsome appearance, the gulper eel is not a fast hunter. Instead, it drifts through the blackness, waiting for small fish or shrimp to swim by. Then, with one sudden motion, it opens its enormous mouth and gulps. Its body can stretch to hold surprisingly large meals, making it a master of rare opportunities in a world where food is scarce. It also has a bioluminescent lure at the tip of its tail, a glowing dot that it can wave to attract prey. In the still black waters of the abyss, the gulper eel is part monster, part illusion, and entirely real. Every night, deep creatures rise toward the moonlight. When the sun sets and the ocean surface grows dark, something extraordinary happens in the deep. Millions of creatures, fish, squid, jellyfish, and plankton begin to rise. Slowly, silently, they migrate upward from the twilight zone to feed in the nutrient-rich upper layers. It's called the Deal vertical migration, and it's the largest movement of animals on Earth. This nightly journey happens across the globe from the tropics to the poles and repeats every 24 hours like a planetary heartbeat. The creatures rise to feed under cover of darkness, then retreat again before dawn to avoid predators. It's a delicate dance between hunger and safety, light and shadow. Most of it is invisible to us, hidden beneath waves and moonlight. But this migration shapes ecosystems, affects carbon cycles, and keeps the deep connected to the surface. In the ocean's rhythm, night is the time to rise. This nightly migration is the largest on the planet. Each evening, trillions of marine animals ascend from the deep, not just a few meters, but sometimes up to a kilometer or more. The sheer scale is staggering. Imagine every living human being rising and falling in perfect synchrony every night. Now multiply that by 1,000. This vertical migration moves more biomass, more total living matter, than any other daily movement on Earth. It helps regulate the planet's climate by transferring carbon from the surface into the deep ocean, where it can remain for centuries. And it does all this in near total silence, far from human eyes. Creatures like lanternfish, hatchetfish, and tiny crustaceans make this trek under the cover of darkness, guided by cues we barely understand. Perhaps temperature shifts or the faint rise of moonlight. It's one of the most important processes on the planet. And we're only beginning to understand how it works. Starfish can regrow entire arms. In the tide pools and shallow seas, starfish crawl slowly across the rocks, their arms stretching like rays of the sun. These creatures possess a remarkable ability. If they lose an arm, they can regrow it completely. In some cases, a single arm can even regenerate into a whole new starfish, given enough time. This power comes from their incredible ability to regenerate cells, rebuilding not only muscle and skin, but also their internal structures. For starfish, this isn't just a trick. It's a survival strategy. When attacked by predators, they can sacrifice a limb and later grow it back. Watching a starfish move with calm determination, you might never guess the quiet resilience hidden in its body. Their ability to heal and renew themselves is a gentle reminder of nature's patience and of the hidden powers life can carry within. Some octopuses carry coconut shells as tools. The octopus is known for its intelligence, but perhaps one of its most charming traits is its resourcefulness. In the waters of Indonesia, scientists have observed octopuses carrying coconut shells across the sea floor. They use their arms to tuck the shells underneath their bodies, shuffling along awkwardly while transporting them. When threatened, they assemble the shells into makeshift shelters, hiding inside their portable armor. This is one of the clearest examples of tool use in the ocean. A creature not just reacting to its environment, but actively shaping it to its advantage. The sight is strangely endearing, like watching a traveler carry a suitcase. In the dark and shifting world of the sea, where danger can come from any direction, the coconut octopus has learned to bring safety with it. A reminder that intelligence takes many forms. Even in the silent deep, they can solve puzzles and escape from tanks. Octopuses are masters of problem solving. In aquariums around the world, keepers tell stories of octopuses that unscrew jar lids, lift latches, and even sneak out of their tanks at night. Some have been found wandering the floor, exploring pipes, or slipping into neighboring enclosures to steal food. Their arms are lined with hundreds of suckers, each capable of tasting and touching independently, like having 8 curious hands. But it's not just dexterity. Octopuses seem to think. They learn from experience, remember solutions, and adapt to new challenges. Watching an octopus carefully unscrew a jar to reach a crab inside feels almost human. A glimpse into a mind both alien and familiar. In the silent waters of their tanks, they remind us that intelligence is not ours alone. It is a thread woven through the ocean in forms we are only beginning to understand. An octopus has 3 hearts and blue blood. The octopus is unlike almost any other creature on Earth. Inside its body, not 1 but 3 hearts beat. 2 of them pump blood through the gills, while the third pumps it through the rest of the body. Even stranger, their blood is not red like ours, but blue. This is because it uses copper rather than iron to carry oxygen. Copper works better in the cold, oxygen-poor waters where many octopuses live. When an octopus swims, one of its hearts actually stops beating, only to start again when it rests. These creatures are reminders that life is endlessly inventive, shaping organs and systems to fit the needs of each environment. To imagine blood running blue instead of red and a rhythm powered by 3 separate hearts is to glimpse just how many ways life has found to thrive beneath the waves. One strange underwater sound was dubbed the bloop. In 1997, a strange and powerful sound was detected by underwater microphones in the South Pacific. It was low, deep, and loud. So loud, in fact, that it was picked up by sensors over 5,000 kilometers apart. Scientists called it the bloop. At first, it baffled researchers. The sound had characteristics similar to those of an animal call, but no known creature could produce a sound so powerful. Was it a whale? A seismic event? Something unknown? Speculation ranged from deep sea monsters to undiscovered leviathans. Eventually, the best theory pointed to the cracking and collapse of massive Antarctic icebergs. But for years, the bloop captured the imagination of oceanographers and science enthusiasts alike. It reminded us that the ocean can still surprise us, that sometimes a single unexplained sound can echo through both water and wonder, stirring the imagination as much as the ear. Some fish communicate by drumming on their own bodies. While whales sing and dolphins click, some fish have evolved much stranger ways to communicate. They drum. Using special muscles attached to their swim bladders, the internal sacs that help control buoyancy, these fish can create rhythmic thumps, pulses, or grunts. It's a bit like beating a drum from the inside out. These sounds can serve many purposes: attracting mates, defending territory, or signaling distress. The toadfish, for example, makes a humming call so loud it can be heard through the hulls of boats. Other fish use short bursts to coordinate with the group or ward off intruders. In the dark, noisy world of the ocean, sound becomes a private language, one that's often overlooked by human observers. These simple drumming rhythms are reminders that even the quietest fish may have a voice, if only we know how to listen for it. Whales dive for miles to sing where no light reaches. Among the deepest divers in the animal kingdom are whales, especially species like the sperm whale and the Cuvier's beaked whale, which can dive over 3 kilometers beneath the surface. They go there to hunt, to hide, and in some cases, to sing. Whale song is one of the most haunting and beautiful sounds in nature. Long echoing calls that can travel for thousands of kilometers. Some whales dive deep before they begin singing, where ambient noise is lower and the sound can carry farther. These songs may serve many functions: attracting mates, locating others, or mapping the sea using echoes. They're so complex that they may even contain dialects or patterns that change over time. In the dark silence of the abyss, a single whale's voice can fill the water like music in a cathedral. It is sound without light, language without land. Giant squid were once sea monsters until we filmed them alive. For centuries, giant squid were the stuff of sailors' nightmares. Glimpsed in fragments, washed ashore in pieces, or tangled in fishing nets. They were called kraken, leviathans, monsters of the deep. No one had seen one alive in its natural habitat until 2012, when Japanese researchers captured the first video of a living giant squid filmed over 600 meters below the surface. What they saw was dazzling. A sleek, graceful creature with shimmering skin and eyes the size of basketballs. Its arms moved like ribboned silk, trailing hundreds of tiny suction cups. It wasn't a monster. It was a mystery made real. The deep sea still holds many secrets, but the giant squid is no longer just a legend. We've seen it. And that glimpse confirmed what mariners had whispered for centuries, that something enormous waits in the dark. Reef-building corals are under threat from warming seas. As beautiful as coral reefs are, they are also fragile. Corals live in partnership with tiny algae that provide them with food and brilliant color. But when ocean temperatures rise even slightly, the corals become stressed and expel their algae. Without their partners, they turn ghostly white, a process called coral bleaching. If the heat continues, the corals starve and die, leaving behind barren skeletons. In recent decades, warming seas have caused mass bleaching events across the globe, threatening reefs that have stood for thousands of years. Yet, there is hope. Some corals are more resilient, capable of withstanding higher temperatures. And scientists are working to protect and restore reef ecosystems. The fragility of corals reminds us that the ocean, for all its power, is also delicate. A living system that depends on balance and one we are called to care for. Entire atolls are built on ancient volcanic foundations. Scattered across the Pacific are rings of islands that look like necklaces floating on the sea. These are atolls, circular chains of coral that enclose tranquil lagoons. Atolls are born from volcanoes. Long ago, volcanic islands rose from the sea and corals began to grow around their edges. As the volcano slowly sank beneath the waves, the corals continued to build upward, keeping pace with the rising water. Over millions of years, the volcanic island disappeared beneath the surface, leaving behind a near ring of coral. The result is a natural wonder. An atoll with calm waters at its heart and the open ocean beyond. To walk across an atoll is to stand on the memory of a volcano transformed into a paradise of sand, palms, and coral. They are reminders that even destruction can create beauty, reshaping the world in unexpected ways. Seagrass meadows produce more oxygen than forests. Beneath the waves, vast meadows of seagrass sway with the current. These underwater plants may seem unremarkable compared to coral reefs or kelp forests, but they are quiet giants in Earth's story. Seagrasses photosynthesize, drawing in carbon dioxide and releasing oxygen. In fact, per square meter, they can produce more oxygen than tropical rainforests. These meadows also act as nurseries, sheltering young fish, seahorses, and turtles among their waving blades. Their roots stabilize the sandy seabed, protecting coastlines from erosion, and they store huge amounts of carbon, locking it away in the sediment for centuries. Yet seagrass meadows are disappearing worldwide due to pollution and coastal development. Protecting them means protecting one of Earth's most important life support systems. To drift above a seagrass meadow is to float over a hidden forest, alive with movement, feeding the air we breathe and keeping our planet in balance. Mangroves protect coastlines from storms. Along tropical shores, mangrove forests stand with their roots tangled like intricate sculptures, half in the water and half on land. These remarkable trees are natural guardians of the coast. Their roots act like living barriers, absorbing the force of waves and storm surges, protecting inland communities from flooding and erosion. At the same time, they provide shelter for fish, crabs, and birds, forming rich ecosystems in the shallow water. Mangroves are also powerful carbon sinks, capturing and storing carbon dioxide in their soil and roots. Yet, like coral reefs, they are under threat from development and climate change. To walk among mangroves is to feel the meeting of land and sea, where trees grow in salt water and roots cradle entire ecosystems. They are protectors and providers, reminders that nature has its own defenses and that the ocean's edge is alive with resilience. Rivers and lakes exist at the bottom of the sea. It sounds impossible, but it's true. Under the sea, there are rivers and lakes, bodies of water within water. These strange features form when dense, salty brine gathers in depressions on the sea floor. Because the brine is heavier than the surrounding seawater, it doesn't mix easily. Instead, it forms shimmering, slow-moving pools with visible shorelines, currents, and even waterfalls. Some are surrounded by mussels and tube worms. Others are eerily still with toxic chemistry that few organisms can survive. Divers and submarines that approach often report a surreal sight, the sensation of flying over a separate sea. These lakes can be tens of meters deep and hundreds wide, complete with waves and ripples. It's a layered world within a world, like a secret ocean hiding inside another. In the deepest reaches of Earth, water doesn't always behave the way we expect. Some undersea pools are so salty they're toxic. At certain depths, the ocean hides something astonishing. Brine pools, where salt concentrations are so high that the water becomes heavier than the sea around it. These pools can be several times saltier than normal seawater, forming dense lakes on the seafloor that don't mix with the ocean above. The chemistry inside is often lethal to most marine life. Lacking oxygen, laced with hydrogen sulfide, and nearly still. Some creatures have adapted to live at the pool's edges, but any fish that wanders too far inside may never come out. Submersibles that explore these pools describe eerie underwater shorelines, complete with rippling surfaces and even waterfalls. The sight of a lake beneath the sea, complete with its own tides and shores, is one of the most surreal discoveries in oceanography. These toxic pools are quiet reminders that the deep doesn't always follow the rules of water. The seafloor isn't flat. It's full of sunken valleys and towering cliffs. When we imagine the bottom of the ocean, it's easy to picture a vast, featureless plain. But in reality, the seafloor is just as rugged and dramatic as any mountain range on land, and sometimes even more so. Deep beneath the waves lie steep escarpments, massive undersea cliffs, sprawling trenches, and volcanic ridges. Some cliffs drop for kilometers in near vertical walls shaped by shifting tectonic plates or ancient landslides. Others form the boundaries of underwater plateaus and fracture zones. Because of the difficulty of mapping the deep, many of these features remained hidden for decades, and some are still being discovered. Just like the continents, the ocean floor is scarred and sculpted by geological time. Every valley is a record of collapse or creation, every ridge a frozen moment of fire. Even where no sunlight ever reaches, the Earth's forces are still at work. Abyssal plains stretch across the ocean like endless deserts. Far below the surface, between 3 and 6 kilometers deep, lie the abyssal plains, vast, flat expanses that cover more than half of the ocean floor. These plains are some of the flattest regions on Earth, formed by the slow settling of sediments over millions of years. But while they may seem barren, they are not lifeless. Tiny organisms burrow in the mud. Scavengers patrol the darkness. Occasional whale falls create oases of life. To visit an abyssal plain is to enter a place where time moves slowly, where silence is absolute, and where each particle of marine snow, organic matter drifting down from above, is a treasure. These plains are both alien and familiar, wide, still, and strangely peaceful. They're the true seabed of the world, stretching beyond the limits of light or sight. They are the ocean's quiet, unmoving heart. Some islands disappear beneath the waves again. Just as the ocean can create islands, it can also take them away. Many small volcanic islands born in spectacular eruptions vanish within years as waves and storms erode their fragile rock. In the Pacific, new islands have appeared and disappeared in the span of a single human lifetime, leaving only faint outlines on nautical charts. Rising sea levels add to this process, slowly submerging low-lying atolls and coral islands. Entire communities in places like the Maldives and Kiribati live with the knowledge that their homes may one day slip beneath the waves. The ocean is both giver and taker, sculpting the land as it pleases. An island may rise like a miracle, only to vanish again, reminding us that nothing on Earth is permanent. Land and sea are in constant negotiation, and the ocean always has the final word. Coral reefs are built by tiny animals. When you see a coral reef, it may look like colorful stone, a solid wall of rock covered in fish and plants. But reefs are actually alive, built by billions of tiny creatures called coral polyps. Each polyp is a small animal related to jellyfish, with soft bodies that secrete limestone skeletons. Over time, these skeletons accumulate, stacking into massive structures that can stretch for hundreds of miles. The reef becomes a living city, growing slowly over centuries as each new generation of polyp builds upon the last. The colors we see come from the algae that live inside the corals, giving them food through photosynthesis. Reefs are not just beautiful. They are vital, providing shelter and nurseries for countless marine species. To swim among coral is to wander through an ancient living cathedral, built one tiny creature at a time across centuries of patience. They support a quarter of all marine species. Though coral reefs cover less than 1% of the ocean floor, they are home to about a quarter of all marine life. Fish of every color dart between the branches. Sea turtles glide gracefully overhead, and tiny creatures build their homes among the coral. This astonishing density of life has earned reefs the nickname rainforests of the sea. For humans, they are equally important. Reefs provide food, protect coastlines from waves, and support millions of people who depend on them for fishing and tourism. Yet, they are fragile, threatened by warming waters and pollution. When corals die, entire ecosystems can collapse, leaving silence where once there was life. To imagine a reef is to imagine abundance, a kaleidoscope of colors, shapes, and movements, all woven together into a single living system. They remind us how rich and interconnected life in the ocean can be. Some corals glow under ultraviolet light. When corals are bathed in ultraviolet light, something magical happens. Their surfaces shimmer with neon colors, glowing greens, blues, and reds that look almost otherworldly. This glow comes from special proteins within the coral that absorb UV radiation and emit it as visible light. Scientists believe this bioluminescence may help protect corals from harmful sunlight, or perhaps attract the tiny algae that live inside them. To divers exploring reefs under special lights, it feels like stepping into a dream where the ocean floor shines like a field of stars. These glowing corals are not just beautiful. They hold secrets that may one day help humans develop new medicines and technologies. In their light, we see both the creativity of nature and the endless curiosity it inspires, reminding us that even the smallest creatures can shine with cosmic brilliance. Others feed on nothing but falling dust. Many deep sea creatures don't hunt, chase, or bite. Instead, they wait. They feed not on other animals, but on tiny particles drifting down from the upper ocean. A slow, steady rain of organic matter known as marine snow. These particles are the remains of dead plankton, tiny fecal pellets, discarded exoskeletons, and other microscopic debris. Though each flake is nearly weightless, together they form the primary food source for vast regions of the seafloor. Sea cucumbers, brittle stars, crabs, and deep-dwelling worms sift through this sediment like scavengers in a cosmic snowfall. In some regions, entire ecosystems are sustained by this delicate stream of nutrients. Life here moves slowly, conserving energy, making the most of every particle. In the deep, there are no fast meals, only patience and the knowledge that even the smallest speck can be a feast. Marine snow drifts down like an eternal ghostly blizzard. Imagine a snowfall that never melts, not of ice, but of organic dust. In the deep sea, marine snow is a constant slow-motion blizzard. Tiny flakes of dead plankton, algae, fish scales, mucus, and microscopic waste drift endlessly downward from the sunlit surface. Most flakes are barely visible. Some clump together, forming delicate webs or pellets. They can take weeks or even months to reach the bottom. But for deep sea creatures, marine snow is life. It delivers nutrients to places where nothing grows, linking the surface world to the abyss in a kind of invisible food chain. Some animals filter it from the water as it falls. Others graze the seafloor, collecting what settles there. It may seem unremarkable, but this soft, silty snowfall is one of the most important biological processes on Earth, connecting life across layers of depth and time. A whale fall feeds life for decades in the deep. When a whale dies and its body sinks to the bottom of the ocean, something extraordinary happens. That carcass, sometimes weighing over 30 tons, becomes a vast temporary ecosystem known as a whale fall. For decades, layer by layer, life moves in. First come scavengers, sharks, hagfish, and giant amphipods that strip away the flesh. Then other creatures move in to feast on scraps and soft tissue. As time passes, the bones themselves become food. Bacteria that feed on fats within the bones release chemicals like hydrogen sulfide, attracting chemosynthetic worms and mollusks, the same kinds of life seen at hydrothermal vents. A single whale fall can support over 100 species of animals, many of which are found nowhere else. In the dark, where food is rare, a whale's body becomes a gift, a slow-burning feast that echoes through the ecosystem for years. Some creatures eat bones and nothing else. Deep in the ocean, where meat is scarce and survival is hard, a few creatures have evolved to do the unthinkable. They eat bones. The most famous of these is the Osedax worm, also known as the bone-eating zombie worm. It has no mouth, no stomach, and no eyes. Instead, it drills into the bones of fallen whales using acid, then absorbs the nutrients inside. To do this, it relies on symbiotic bacteria that help it digest fats and collagen. These worms grow root-like tendrils that anchor into the bone, while feathery plumes extend from their bodies to extract oxygen from the water. They are delicate, ghostly, and oddly beautiful. A perfect example of life adapted to extremes. In a world where food arrives once in a generation, nothing is wasted. Even bones become a banquet. Even decay becomes life. The Southern Ocean encircles Antarctica with endless winds. At the bottom of the world lies a restless ocean unlike any other. The Southern Ocean circles Antarctica completely unbroken by continents. Because of this, its currents can race all the way around the globe, creating the strongest continuous flow of water on Earth. These currents connect the Atlantic, Pacific, and Indian Oceans, mixing their waters and regulating Earth's climate. The winds above the Southern Ocean are equally powerful, whipping the seas into towering waves that crash against the icy continent. Despite the harshness, life thrives here. From vast colonies of penguins to pods of orcas and humpback whales, the Southern Ocean is a reminder that even at the planet's edge, where cold and wind seem unrelenting, the sea remains alive, circling endlessly. It is like a great belt of water and air, binding Earth's oceans into a single living system that never stops moving. The Arctic Ocean is covered by shifting ice. The smallest of Earth's oceans, the Arctic, is capped by a vast sheet of floating sea ice. This frozen lid is never still. It cracks, drifts, and reforms with the seasons, creating a shifting, ever-changing landscape. In summer, the ice retreats, opening passages of water and exposing hidden ecosystems beneath. In winter, it expands again, stretching into a frozen desert. Beneath the ice, life carries on in quiet resilience. Plankton bloom in the sunlight, filtering through the ice. Fish glide below, and seals hunt in the cold, silent dark. Polar bears wander across the frozen surface, depending on the ice to hunt. As the climate warms, the Arctic Ocean is changing faster than almost any other place on Earth. The melting ice is a reminder that this frozen sea is not eternal. It is fragile, shifting, and deeply connected to our world's future. The ocean's surface hides mountain peaks taller than the Alps. The ocean may look flat and endless from above, but beneath its surface lie mountains taller than the Alps. Seamounts, underwater mountains formed by volcanic activity, rise thousands of feet from the sea floor. Many never reach the surface, their peaks hidden just below the waves. Some are higher than Mount Rainier, yet completely invisible from land. These seamounts create unique ecosystems as currents swirl around them, bringing nutrients that attract fish, corals, and whales. Entire communities form in these hidden places, thriving in the shadow of underwater peaks. To think that such towering mountains exist, unseen beneath the waves, is humbling. They remind us that most of Earth's wonders remain hidden from sight. The next time you gaze at the horizon, remember just below that calm surface, peaks taller than alpine summits rise silently through the deep, unseen and unknown. Some trenches are so deep they could swallow Mount Everest. The ocean is home to immense chasms that make even the greatest mountains seem small. The Mariana Trench, the deepest known, plunges nearly 7 miles beneath the surface. If Mount Everest were placed inside, its peak would still be submerged by more than a mile of water. These trenches are formed where tectonic plates collide, forcing one beneath the other into the Earth's mantle. They are some of the most extreme environments on the planet, dark, cold, and under crushing pressure. Yet, even here, life exists. Strange organisms cling to the rocks, feeding on nutrients that drift down from above or emerge from deep within the Earth. These trenches are not just scars on the sea floor, but doorways into the unknown. To imagine their depth is to imagine standing at the base of Everest and still looking up through miles of dark water. Cold and darkness slow down time for living things. Life in the deep ocean moves at a different pace. Temperatures often hover just above freezing, and light never penetrates past a certain depth. These conditions change everything, especially time. Cold temperatures slow metabolic rates, allowing animals to conserve energy and reduce wear on their cells. Many deep sea creatures grow slowly, reproduce rarely, and live for decades or even centuries. A single meal might last for weeks. A generation might stretch across half a century. In the absence of light and warmth, evolution favors stillness, patience, and endurance. What feels like a moment on the surface might be a year in the deep. This slowness is not a weakness. It's a strategy. In a world where food is rare and change is gradual, living slowly means living well. In the deep, time flows like the cold water, vast, gentle, and unhurried. Some fish survive by producing their own antifreeze. In the coldest parts of the ocean, where temperatures dip below freezing, many fish would freeze solid without special adaptations. But some have evolved a clever solution: antifreeze proteins. These proteins circulate in their blood and tissues, binding to ice crystals and preventing them from growing. It's the same basic principle as the antifreeze in a car, but far more elegant. These antifreeze-producing fish are found in polar oceans and deep, frigid waters. Their bodies remain soft and flexible even in the cold, allowing them to move, feed, and survive in environments that would otherwise be fatal. Scientists have even studied these proteins to improve cryopreservation techniques on land. It's a reminder that extreme cold isn't always a barrier. In nature, it's a challenge. And evolution loves a challenge. Where ice would stop most hearts, these fish keep swimming. Others are so soft they'd collapse if brought to the surface. Some deep sea creatures are made almost entirely of gelatinous material, soft, delicate, and nearly formless. At great depths, this softness is an advantage. Without a rigid skeleton, they can resist the crushing pressure simply by being flexible. But if they were suddenly brought to the surface, they'd collapse. Not from injury, but because their bodies depend on high pressure to maintain shape. The famous blobfish, for example, looks like a saggy cartoon on land, but at its natural depth, it's sleek and well-formed. Other creatures like certain jellies or comb jellies would disintegrate almost instantly in normal air pressure. These animals have evolved for one specific environment: the deep. Their beauty is fragile, their survival is precise, and their bodies are shaped by forces most of us will never feel. The invisible weight of miles of water pressing in from all sides. Some deep creatures have no bones at all. In the crushing pressure of the deep ocean, softness becomes a form of strength. Many creatures here have no bones, no rigid skeletons or hard shells. Instead, they're made of soft tissues, cartilage or gelatinous material that can bend and flex with the water around them. This makes them incredibly pressure tolerant. While a bony body might crack or collapse, these creatures simply compress and expand as needed. Some look like drifting ghosts, others resemble ribbons, umbrellas, or glass sculptures. Their softness isn't a flaw, it's an exquisite adaptation. Even fish that do have skeletons often have lightweight, flexible bones or reduced structures that give them more mobility and less fragility. In the deep, structure is secondary. Survival means yielding to the environment, moving with the currents, and staying quiet in the dark. These soft-bodied wonders remind us that vulnerability can also be resilience. Entire ecosystems exist with no sunlight ever. Most of life on Earth depends on sunlight. Plants capture it, animals eat the plants, and the cycle continues. But deep in the ocean, far beyond the reach of even the faintest ray, entire ecosystems exist in complete and permanent darkness. These aren't just a few stray species. Around hydrothermal vents and cold seeps, scientists have found dense communities of life. Tube worms, shrimp, crabs, mussels, and strange fish. There are no photosynthetic plants, only organisms that live by chemosynthesis, using chemical energy instead of light. These ecosystems don't depend on the surface at all. They form their own closed worlds powered by the heat and elements leaking from inside the Earth. When these environments were first discovered in the 1970s, they upended our understanding of what life needs. And they offered a possibility even more profound, that life might not need sunlight at all. Instead of photosynthesis, life down there runs on chemistry. Sunlight fuels almost every food chain on the planet, except in the deep ocean. Here, something remarkable happens. Life runs on chemistry. Around hydrothermal vents and methane seeps, microbes use the energy stored in chemicals like hydrogen sulfide, methane, and iron to create organic matter. This process, called chemosynthesis, allows life to flourish without the sun. It's similar to photosynthesis, but instead of light, it uses molecules from the Earth itself. These chemosynthetic microbes form the base of entire ecosystems, feeding tube worms, clams, and crustaceans that gather in dense colonies around vents. It's a different kind of energy, ancient, elemental, and invisible, and it may be one of the earliest forms of life on Earth. Some scientists even believe chemosynthesis could support life on other planets or moons. In the deep sea, chemistry becomes cuisine, and life rewrites the rules of survival. Microbes feed on sulfur that leaks from Earth's crust. At hydrothermal vents, the water gushing out isn't just hot. It's full of dissolved minerals, including toxic chemicals like hydrogen sulfide. This gas would be deadly to most surface life. But in the deep, certain microbes have evolved to feed on it. These sulfur-loving bacteria form dense mats on rocks, coat vent chimneys, and even live inside the tissues of larger animals. They use the energy from the sulfur to fuel chemosynthesis, creating sugars and organic molecules that support other life. Some tube worms have no mouths or digestive systems at all. Instead, they house these microbes within their bodies and absorb the nutrients they produce. It's a remarkable partnership. Sulfur from the earth, microbes from the deep, animals from the dark. Together, they form ecosystems as rich and complex as any coral reef without ever needing light. These tiny organisms power entire deep seafood webs. In the deep, where no light penetrates, the smallest creatures often carry the greatest weight. Chemosynthetic microbes, though invisible to the naked eye, form the base of deep sea food chains around vents and cold seeps. They transform toxic chemicals into energy, producing organic matter that feeds shrimp, crabs, mollusks, and other vent dwellers. These in turn feed larger predators like deep-dwelling fish or octopuses. Every life form in the system ultimately depends on the microbes, even if they never interact directly. It's a web that doesn't begin with sunlight, but with sulfur, methane, and iron. Without these microscopic powerhouses, the vent communities would collapse. Their role is quiet, constant, and vital. And because chemosynthesis might predate photosynthesis, these microbes may represent one of life's oldest strategies, a kind of living memory from the earliest oceans. In their simplicity lies the key to an entire hidden world. Cold water corals build vast cities in the dark. Coral reefs aren't just tropical. In the freezing depths of the ocean, far from sunlight, cold water corals quietly build vast, complex structures that rival their shallow water cousins. These corals don't rely on photosynthesis. Instead, they catch tiny particles of food drifting through the current using delicate feathery arms. Over thousands of years, they grow into massive reefs, some stretching for kilometers. These reefs provide shelter for countless deep sea species, fish, worms, crustaceans, and sponges. They're hotspots of biodiversity in an otherwise sparse world. Many cold water corals grow slowly, just a few millimeters per year. But given enough time, they can form underwater cities teeming with life. These reefs are hard to reach and only recently mapped by sonar and submersible expeditions. Some have already been damaged by trawling or climate change. But even in the darkness, they continue to grow. Delicate fortresses sculpted by time. Some coral reefs are older than human civilization. In the deep ocean, coral grows slowly, sometimes just a few millimeters per year. But given enough time, that slow growth becomes something monumental. Some cold water coral reefs are estimated to be more than 8,000 years old, meaning they began forming before the first cities were built on land. These reefs are hidden in darkness, built by creatures that never see the sun. And yet, over centuries, they form towering mounds and sprawling habitats that shelter entire ecosystems. Each new coral polyp builds on the skeletons of those that came before, layer upon layer across millennia. While shallow reefs often come and go with the tides of warming oceans, some deep reefs have endured ice ages and survived the shifting of continents. These aren't just reefs. They're living archives built slowly in silence, telling stories that long predate our own. Deep water corals grow without ever seeing the sun. Unlike the bright corals of tropical shallows, deep water corals have no need for sunlight. They don't rely on algae for food as their surface-dwelling cousins do. Instead, they capture small bits of drifting organic matter from the water around them. Tiny particles of marine snow, bits of dead plankton, and microscopic life. These corals grow in cold, dark water, sometimes more than 1,000 meters deep. Their shapes vary wildly: spirals, fans, branches, and curls. Some glow faintly under special lighting, revealing colors hidden from natural view. Though they live far from human eyes, they are vital to deep-sea biodiversity, forming reef structures that act as shelters, nurseries, and hunting grounds. Their beauty is subtle, often seen only through the lens of a remote camera. But it's there, intricate, delicate, and undiminished by darkness. New coral reefs are still being found today. With all our technology, it might seem like we've already discovered most of what Earth has to offer. But in the deep ocean, surprises still wait. In recent years, scientists have discovered entirely new coral reefs. Some stretching for kilometers, others hidden beneath submarine cliffs or along continental slopes. One reef off the coast of South Carolina was over 130 kilometers long and previously unknown. These discoveries often happen by accident. A sonar scan, a passing submersible, or a curious blip on a map. The deep is vast and largely unexplored, so it's likely that many reefs and the life they support remain unseen. With each new reef comes new questions. How old is it? What species live there? How can it be protected? Even now, the ocean continues to surprise us. And every new reef is a quiet reminder that Earth still holds secrets. We use robots to explore where no human can swim. The deep ocean is a place of extremes. Freezing temperatures, intense pressure, and absolute darkness. It's no place for unprotected humans. So instead, we send robots. These machines, called ROVs, remotely operated vehicles, are equipped with cameras, lights, robotic arms, and sensors. Piloted from ships at the surface, they can dive for hours or even days, transmitting real-time video and data from miles below. Some can hover above vents. Others collect samples, measure temperature, or map terrain with sonar. They've been used to discover new species, study deep-sea ecosystems, and even locate shipwrecks lost for centuries. The footage they return is often breathtaking. Glowing jellies, towering coral, volcanic landscapes. These robots don't just extend our reach. They extend our imagination in a world we cannot visit ourselves. They go in our place, eyes in the dark, explorers of the unseen. Some drones dive for hours, beaming back glimpses of the unknown. Many of today's deep-sea drones are autonomous, meaning they don't need constant human control. These AUVs, autonomous underwater vehicles, follow programmed paths, gliding through the ocean in search of data. Some map the seafloor in high resolution. Others measure temperature, salinity, or chemical signatures in the water. Equipped with cameras, lights, and sensors, they can drift through the abyss for hours, even days, sending their findings back via satellite when they return. These drones can explore tight spaces, follow currents, and enter regions that would be too risky for human divers or tethered robots. They've found hydrothermal vents, coral gardens, and entire ecosystems we didn't know existed. And with every mission, they teach us something new. In the deep, where even light cannot go, machines carry our curiosity, quietly charting a world we've only just begun to understand. A few submarines can carry humans to the ocean's abyss. While most deep-sea exploration is done by robot, a few specialized submersibles are built to carry human passengers all the way down. These vessels are shaped like reinforced spheres, able to withstand crushing pressures many kilometers below the surface. Inside, explorers sit shoulder to shoulder in cramped darkness, peering through tiny windows or watching live feeds from cameras outside. The experience is quiet, surreal, and otherworldly. A slow descent into cold silence. Only a handful of humans have ever visited the Challenger Deep, the deepest known point in Earth's oceans. Most descents last several hours, with only minutes spent on the seafloor. But what's seen there leaves a lasting mark. Alien landscapes, strange creatures, and the inescapable sense of isolation. These manned dives are rare and dangerous, but also deeply human. In a world mostly beyond our reach, sometimes we still choose to go in person.